This is the first lecture for HBL on force and pressure. Okay, this is recorded for the sake of those who have missed out the lesson due to the fiesta. Right, for the first part on force and pressure. Now, if you don't have this set of notes, I've already uploaded onto Google Classroom. Please print it up on your own and use that as you watch this video. Now, for the first part, okay, we'll talk about the different types of forces. First of all, what is a force? A force is simply put just a push or a pull, okay, due to the interaction between different objects. Okay, so for example, if I have a ball, right, now by itself, it will not be able to exert any force, okay, or if there isn't anything around, unless I have a second ball with me, correct? Okay, so if I collide with the first ball with the second one, right, it will cause the second ball to move. Okay, so in between them is what we call a force, right, due to interaction between with the first object. Okay, so this is a force. It's a force. Okay, when a force is exerted, right, there can be different effects. So one thing, you can start an object to move, or you can stop it from moving. You could slow it down, you could speed up. Okay, you could even change the direction of the motion of the object. Now, there are actually two different type of forces, right? So as we have seen from this example, right, for this ball to move, right, it first requires a contact between the two objects, right? So one of the two types force is called a contact force, okay? And then out of the contact forces, okay, there's one of it is called the frictional force, okay, which basically is a force that opposes motion, okay, between surfaces that are in contact. Okay, another kind of frictional force, right, which is called that's exerted by the air, we call this the air resistance. Okay, so for example, imagine yourself running through uh, a gust of wind, right? As you're running past through the wind, you will feel some air, right, brushing through you. Okay, so this is what we call the air resistance. Okay, another kind of force is the one that you're experiencing now as you're sitting on a chair. Okay, so for example, if you're sitting on the chair, right, you have a force exerting on you, and that's called your weight, right? Now, why hasn't you sunk into the ground? Right, the reason is because there's an opposing force to that weight, right, and that's called a normal contact force, right? The word normal suggests that it's actually, it has the meaning of perpendicular. So it's actually a normal, a perpendicular force, okay, to the surface that's exerted. Okay, normal contact force. Okay, last one is called tension, right, which basically is just the force that you get when you pull a string, right? When you pull a string, uh, you will experience a pull by the string, right? This pull is called the tension. Okay, Now, other than a contact force, there can be a non-contact force. Okay, so one example is the pull exerted by the gravitational field. Okay, that is called your gravitational force. Okay, another kind of force is between electric charges. Now, if you remember that an atom contains your nucleus, protons plus neutrons, that makes up your nucleus, right? Then there's also electrons that's orbiting around the nucleus. Now, if you recall, electrons has a negative charge, while proton has a positive charge. Now, based on these different charges, these are called electric charges, right? They can be positive and negative, and based on different charges. So, for example, if I have electrons, right, there's minus with another electron. If they are like charges, they will repel. Okay. Then if they are unlike charges like electron and a proton, okay, they will attract. So these are called electrostatic charges, electrostatic forces, sorry. Okay, last but not least, it's actually a magnetic mag- magnetic forces. Okay, there's an attractive and repulsive force between magnets. So something you have learned it since primary school. If it's unlike poles, okay, unlike poles will attract. Okay, if it's like poles, it will repel. Okay, so it's similar to your electrostatic forces. If you have like charges, that means charges that are alike, then they will repel. If you have unlike charges, okay, they will attract. Okay, I'll leave this for a while for you to make any copy. Okay, now let's try an example question. Okay, indicate whether the following scenario are an example of a contact or non-contact forces. Okay, so for the first one, kicking a ball, right? That is definitely a contact force. Okay, for part B, a backrest supporting a person on a chair. Okay, there's contact, so it must be a contact force. Part C, resistance from the wind, right, while running. So even though you are not able to see the wind, right, that does not mean there's no contact, right? Between you and the air, there's some contact, so there must be a contact force. Okay, D, blanket falling off the hanging pole. So the blanket can fall, right, regardless whether there's anything blocking it or not, right? So um, this is an example of a non-contact force, right? It does not need any contact. Okay, part E, two magnets attracting from a distance, non-contact force. Right, but if you think about it, what happens um, when the two magnets collide? what happens when the two magnets collide? Okay, then it will become a contact force, right, when they smash on each other. Okay, now is mass the same as weight? Okay, this will be the next segment.